All right, in 5.4 part 2, we are going to take a look at B and C shifts of graphs of sine and cosine. So remember, from our generic form of all the shifts, okay, B and C would show up here. Okay, B is a horizontal stretch and C is a horizontal shift. So let's jump right in. Okay, if we look at a B shift, okay, that is changing the period. Okay, if you remember, we talked about one period of sine and cosine occurs over a distance of 2 pi, right, from 0 to 2 pi. If a trig function has a b value, the period will change. Okay, and the way that we calculate our new period is this. We just take 2 pi divided by whatever the b value is, right? Then to obtain our 5 key points, we would split up our new interval into 4 equal subintervals. Okay, so let's look at an example of what I mean here. So here we have our graph or our equation, y equals sine of 1/3 x. So to find our new period, all I'm going to do is take 2 pi divided by my b value, which is 1/3. If I'm dividing by a fraction, that's the same as multiplying by the reciprocal, right? So this would really be 2 pi over 1 times 3 over 1. So my new period here is actually 6 pi over 1, right? Or just 6 pi. So instead of going from 0 to 2 pi, I'm going to go from 0 to 6 pi. Now, we want to think about then splitting that interval up into equal parts, right? 4 equal parts so that we have our 5 key points. The easiest way to do that is to just take the average of my starting and ending point, okay? If I'm starting at 0, that's pretty easy to do, right? Halfway in between 0 and 6 pi would be 3 pi. And then we'll just do the same thing, right? For this interval, we'll go halfway in between 0 and 3 pi. Well, halfway in between, again, if we think about taking the average, that would be this plus this divided by 2. So 0 plus 3 pi divided by 2 would be 3 pi over 2. Same thing here. If I want halfway in between 3 pi and 6 pi, I would take the average. So 3 pi plus 6 pi divided by 2. That would be 9 pi over 2. So those are going to be my key points on the x, or on the x-axis, right? So 0, and again, just make sure you're going in equal space when you're graphing these, okay? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So then, in this case, we don't have an a value, right? So I know that I'm just going to be going from 0 to 1 and from 0 to -1. My amplitude is just 1. We are graphing sine here. So we know the basic shape of sine is start at the midline, go up to the maximum, back to the midline, down to the minimum, and then back up to the maximum. And connect. Okay, so here is one period of sine of 1/3 x. And we'll put our arrows on the end just to show that this does continue on. Okay, so if we have a b value, that changes the period. Let's try one more example here. So let's do cosine of 3x. Okay, so again, the period is just 2 pi divided by the b value. So here my b value is 3. Well, that's all the simplifying I can do. My new period is 2 pi over 3. So I want to split the region from 0 to 2 pi over 3 up into fourths. Okay, well, to start, okay, let's cut that in half. So half of that region, again, we can think about adding these together and dividing by 2. So 0 plus 2 pi over 3 divided by 2. That would be the same as multiplying by a half. So that would be 2 pi over 6 or just 1 pi over 3, right? Hopefully that makes sense. Half of 2 pi over 3 is 1 pi over 3. Then we'll take half of each of those intervals. So from 0 to pi over 3, again, if I take the average, that'll be the middle point. So 0 plus pi over 3 would be pi over 3 divided by 2 would be pi over 6. Right. Then here, 1 pi over 3 plus 2 pi over 3 would be 3 pi over 3, or just pi, right? Divided by 2 would be pi over 2, okay? Taking the average is going to be the easiest way to find a point that's exactly halfway in between two other points, okay? So those will be my values on the x-axis, starting at 0, then pi over 6, pi over 3, pi over 2, and ending at 2 pi over 3. Again, we don't have an amplitude change, so my amplitude is 1, so I'm going up 1 and down 1 from the midline, which is just the x-axis because there is no d value. Now this time we are graphing cosine. Cosine starts at the maximum, goes to the midline, goes to the minimum, back to the midline, back to the maximum for our one period. And remember, don't make this look like a V, okay? Make this look like a wave. Right? And we can put our arrows on there. Okay, so again, a b value changes the period. Okay, now I just want to show you one example, since we aren't, necessarily drawing these to scale to each other. Right here is an example of sine of 3x compared to sine of x compared to sine of 1/3 x. Right, this is what it would look like to change the period. Okay, if we have a large b value, that's going to make the period much shorter. Okay, so this will oscillate much more quickly. If we have a much smaller b value, that's going to stretch out our graph. Okay, so just to give you a visual of what the b value would actually do. Okay, so now let's take a look at a c value. Okay, a c value is going to shift our graph left or right. Okay, now remember, we talked about this in the first semester. If we are subtracting, that's going to be a shift to the right. And if we are adding, that's going to be a shift to the left. Okay, now, normally, one period would go from 0 to 2 pi. So what we are going to do is take whatever our c value is and add or subtract it to 0 and to 2 pi to find our new beginning and ending points on the x-axis. So here, right, x minus pi over 4, that means I'm shifting to the right pi over 4. So what that means is I am going to be adding pi over 4 to 0. So I'm going to do 0 plus pi over 4. So my beginning value on the x-axis is pi over 4. And then my ending value, well, I'm just going to add pi over 4 to 2 pi. Here we would need to get common denominators to add these accurately, right? So I could make this 8 pi over 4. Plus 1 pi over 4 would be 9 pi over 4. So I'm beginning at pi over 4, ending at 9 pi over 4. I'll sketch it down here. So just like we did in our first few examples, I need to split this up into fourths, okay? I need to find first what's halfway in between. And to do that, we can find the average, okay? Average is just adding the first and the last and dividing by 2. So pi over 4 plus 9 pi over 4, that would be 10 pi over 4, divided by 2, we could say would be 10 pi over 8, or we could reduce that to 5 pi over 4. Right, then we want to do the same thing. Okay, I want to find halfway in between each of those to split this up appropriately. So pi over 4 and 5 pi over 4 would be 6 pi over 4, divided by 2 would be 6 pi over 8, or 3 pi over 4. And then finally, 5 pi over 4 plus 9 pi over 4, that would be 14 pi over 4, divided by 2 would be 14 pi over 8. Reduce that. This would be 7 pi over 4. So those are my 5 key values on the x. Now, I'm not starting at the y-axis. I'm not starting at 0. So we need to make sure that that first key point, that pi over 4, is appropriately spaced over this way. Okay? So you can say we'll start here at pi over 4. Okay? Then 3 pi over 4, 5 pi over 4, 7 pi over 4, 9 pi over 4. Okay, this time we are graphing sine. So sine starts at the midline, goes up to the maximum, which I guess I forgot to mark that here. There is no change in amplitude, so we're just going between 1 and -1. So this is what our basic shape of the sine curve would look like. So sketch out our 1 period. Okay, so a C value shifts our graph either to the left or to the right. Okay, let's do one more example. So this one, we're going to be shifting to the left. Okay, so my beginning, okay, I'm going to have 0 minus pi over 3. So I'm starting at negative pi over 3. Then I'm ending at 2 pi minus pi over 3. So that would be 6 pi over 3 minus 1 pi over 3 would be 5 pi over 3. Okay, so now this time, my beginning value is going to be to the left of the y-axis. So again, we now need to split that up into fourths. So if I'm starting at negative pi over 3 and going to 5 pi over 3, first, let's find the value that's right in between. So again, taking the average, negative pi over 3 plus 5 pi over 3 would be 4 pi over 3. Divided by 2 would be 4 pi over 6, which would reduce to 2 pi over 3. Then cut each of those in half. So first, negative pi over 3 plus 2 pi over 3 would be 1 pi over 3. 1 pi over 3 divided by 2 would be 1 pi over 6. Then 2 pi over 3 plus 5 pi over 3 would be 7 pi over 3. Divided by 2 would be 7 pi over 6. Okay, so when we are putting these values on our axes, we kind of need to think about appropriately spacing negative pi over 3 to pi over 6. Okay, so I could think about this as negative 2 pi over 6. To accurately space, right? Okay, and again, you don't have to be super accurate here. I just don't want you, using the y-axis, say, as pi over 6 or something like that. Okay, I just want us to be as close to accurate as possible, right? So I could say this is negative 2 pi over 6, negative pi over 6, 0, pi over 6. So here, I'm going to say that the space in between each of my intervals is 3 spaces, right? I'm going to say each one is pi over 6. So then next, we'd be at 2 pi over 3, then next 7 pi over 6, then next 5 pi over 3. Okay, so as long as you are correctly labeling your graph, right, that's what I want. Right? I'm not going to be super picky. on how many spaces you put in between these. All right. So now I'm graphing cosine, but I guess again we should put our y-axis labels on there. So now we're graphing cosine. So I'm starting at the maximum, going to the midline, minimum, midline, maximum. So my cosine graph is going to look something like this. Okay? So our C value shifts our graph left and right. Let's look at a couple of examples now where we have both a B and a C shift. Okay? So what we want to do if we have both a B and a C, we just want to take that whole thing that's on the inside and set it to 0 and 2 pi, okay, like we just did if there was just a C value. Okay, but now I'm going to take that whole thing, set it to 0 and 2 pi. All right, so my beginning, I'm going to say 1/2 times x minus pi equals 0. Solve that. Okay, so if I multiply both sides by 1/2, well, 0 times 1/2 would just go away. So I just have x minus pi equals 0. Add the pi over, and this tells me I'm going to start at x equals pi. Well, now my end, I'm going to say 1/2 times x minus pi equals 2 pi. Multiply both sides by 2, right, to get rid of that 1/2. I'll get x minus pi equals 4 pi, right, because I multiplied both sides by 2. Add the pi over, and I'll get x equals 5 pi. So my starting point is going to be at pi, and my ending point is going to be at 5 pi. Okay, now I'll put this down here real quick, but hopefully this is a simple one to find the points in between. Right, halfway in between 1 pi and 5 pi would be 3 pi, and halfway in between 1 pi and 3 pi would be 2 pi. Halfway in between 3 pi and 5 pi would be 4 pi. Okay, so those are my key points along the x-axis here. 1 pi, 2 pi, 3 pi, 4 pi, and 5 pi. Again, we don't have an amplitude change, so we'll just be going in between 1 and -1. And this time I'm graphing sine. So I am starting at the midline, going up to the maximum, back to the midline, down to the minimum, and back up to the midline. So here is what my one period of sine is going to look like. Okay, so both a B and a C, right, changes the period and shifts my graph. Let's do one last example, right, cosine. So again, to begin, right, I want to set that whole thing on the inside equal to 0. So 2 times x plus pi over 4 equals 0. Divide both sides by 2, and we'll just get x plus pi over 4 equals 0. Subtract the pi over 4, and we can see that we are beginning at negative pi over 4. My ending value then, I'm just going to set 2 times x plus pi over 4 equal to 2 pi. Right? Divide both sides by 2, and we'll just get x plus pi over 4 equals pi. Subtract the pi over 4, and we'll get x equals 3 pi over 4. So I'm starting at negative pi over 4 and ending at 3 pi over 4. Okay, so halfway in between there. Negative pi over 4 plus 3 pi over 4 would be 2 pi over 4. Divided by 2 would be 2 pi over 8, or just 1 pi over 4. Then halfway in between negative pi over 4 and pi over 4 will be 0, right? So the y-axis will actually be one of my key points. And then halfway in between pi over 4 and 3 pi over 4 would be 2 pi over 4, or just pi over 2. So let's label those points. Negative pi over 4, 0 is actually one of them. Pi over 4, 2 pi over 4, or pi over 2, and 3 pi over 4. Now I am graphing cosine, right? And there isn't an amplitude change. So that means I'm starting at the maximum of 1, going to the midline, the minimum, to the midline, to the maximum. So here is what one period of cosine would look like for this graph. Okay? So that is it for this video. The final question is going to pop up asking you what questions you